Hi everyone, my name is Anvita Bansal and we are back with another lecture based on bit manipulation. Let me just quickly check if you guys are able to see my screen. Give me a moment. I think so we are live. Okay, so we are live. Okay, let me just show you the problem statement quickly. Okay, so we are almost at the second last problem from your SD sheet in bit manipulation, which is alone in a couple. So let's see what is your problem statement. So this is also a very easy question of bits. So what you are given is actually this question obviously can be done in the brute force approach, but we will take up using bits so that you can understand that how we are utilizing bit masking here. So let's see, you are given in a party of n people, you're given an array which contains n people, okay, and there are couples which are represented by the same number, and there will be only one person in the in this array of integers which will not be in a couple. That means the person is single. So you have to return that single person which is represented by integer here. Okay, so how will you determine this? If you observe the array, what is this array? It contains 1 2 3 2 1. So if you closely observe, you have 1 in pair. When you're getting two ones, that means they both are a couple. You're getting two twos, that means they have also come in couple. When you have 1 3, that means 3 is the person which needs to be returned because 3 has come in single. Okay, so only the number 3 is single. That's what you have to return. Same goes for this array. If you check what all integers are present in pairs, so 1 1, we have 2 2, we have 3 3, we have 4 but no other 4. And also the question ensures, the problem ensures that you have only one such single person only. There will be only one such person who hasn't come in a couple. So whenever you spot it, you have to return it. So how can we do this problem? So clearly, if I want to solve this problem, I can easily iterate over the entire array. You given an array like this: 1 2 3 1 2. For example, this is your given array, so I have to return 3. So in the brute force approach, I can clearly iterate over this entire array, check which number has frequency 1, and I will return it, right? So this can be done in multiple ways. You can create a hash map to check the frequency. Then you can also sort this array, and then in the sorted array you can compare with the previous number. Wherever you find that the number is not present, that is not equal to its I minus 1th position, you can figure out that that's the person that needs to be returned. So there are plenty of ways, but how can we do it in using bit manipulation? So let's have a look here. See, you're given an array of integers, right? One property, if you remember, so I'll just tell you what we are going to use here. It's XOR. Bitwise XOR is what we are going to use here. Now just give a bit stress on your mind how XOR will come to our rescue for this problem, how the property of XOR is going to help us. So before we move into how we solve this problem, let me just tell you again what is the truth table of a XOR, or not even truth table. You just need to know that in terms of bits, whenever I have different bits, I get resultant as 1. Okay, so if I have 0 1, my result is 1. If I have 1 0, my result is 1. For XOR truth table, right? If I have two similar bits 0 0, my resultant is going to be 0. 1 1, my resultant is going to be 0. So that's how the truth table of XOR looks like. Now if I tell you, now the answer is pretty clear in front of you, that this is what we are going to do. Now how are we going to do this? So if I take some numbers, let's say we have 1 2 3 1 2, right? Okay, just give me a second, I'll just have a table here. I am just taking the test case which I'd like to iterate over and explain to you, so I'm just looking forward to the numbers. So if I take these numbers only, okay, and what I want you to know is, if I'm just writing, this is for the representation purpose only, okay, for the representation purpose. When I operate on these integers and I'm operating with some bitwise operation, then obviously it is going to operate on the, either way it is going to operate on the binaries of these number. So just see, if I write the binary representation, very simple. So let me just take 2 bits only, 0 1, then I'm gonna have, 1 second, we're not taking 0 into consideration, then we have 1 second, 1 0 1 1 1, then we have 1, then we have 2. Okay, let's take these numbers. Now what? Now if you use, let's take some number x equal to 0 0, fine. Now tell me, if I do x XOR with this first number, what am I going to get? So 0 0 doing its XOR with 0 1, what is your resultant going to be? Different bits 1, same bit 0. So do you see the resultant is exactly equal to this number? Let's say this number is a, actually this number is b, this number is c, this number is again a, this number is again b. Okay, so when I'm doing a XOR with 0, when I'm doing a XOR with 0, I am going to get a, right? If I do a's XOR with a only, that means same bits, my resultant will be 0, right? So keep repeating this process. If I keep repeating this process, what I'm going to get? When I did XOR of x with a, I got a only. Now since I got a, I'll do its XOR with b. B is what? It's a different number. Obviously it's a different number, so different bits, what I'm going to get here? A, and then I've got, then there is this b, 1 0, different bits 1 1. Okay, fine. Now do, this is the number, subsequent number I've got, do its XOR with what? C. Okay, when I do its XOR with c, you can see that it is the same number. I'm going to get 0 0, fine. Do its XOR with a again. Now I've got this number. When I'm doing its XOR with a, what I'm going to get? Different bits, I'm going to get 1, and same bit 0. So this is equal to a only. Okay, now I have to do its XOR with what? B, that is 1 0. So when I'm doing its XOR with b, what I'm going to get? 1 0 is 1, 0 1 is 1, because these are 2 different bits. Now tell me, what is the resultant equal to? Don't you see that 1 1 is the binary representation of C, and what your C was actually? So in your array, your C belongs to 3. See, this is 3. So what did you see here? When I am repeatedly doing XOR of number, wherever whenever it finds its pair, its couple, it is going to become what? It is going to be 0. Whenever it finds a different entity, it is going to finally return that different entity which does not exist in pair. That's a simple thing, right? So it's as simple as doing like this. A's XOR with 0 will return me a. Okay, now a XOR with b, okay, it's some different entity, that is what I got. Then it's XOR with, that's what you can do. So I hope you understood the gist of this problem. This is the property that we are going to use, and finally you will be left with the answer which is present in the array as a single unit. You do not have its duplicate. So that's all about this problem. Let's move to the code and solve it quickly. It's very easy. So I'll iterate over this array for int. For int, I'll take a belonging to arr. Okay, what you are checking? You are checking you have taken some int x as 0, whose XOR you will start with. So then you are doing what? Your x, each time you are updating your x with x XOR with what? A, right? That's what you are doing. And then finally you return x. So x finally will have that value. X finally will have that value which is present in your array. Okay, so return x. Meanwhile, I'll just check if you guys have any doubt. Let's submit it. Okay, you can write in the chat if you have any doubts, and we are almost towards the end of entire bit manipulation. One more question to go. We'll take that up tomorrow. That's all for today then, guys, if you do not have any doubts. Okay, so let me know if you have any doubts. I'll take that up. Fine, then that's all for today. Hope you all understood this problem, and yeah, see you all in the next lecture then. Bye bye, take care.